ask you. Hi.
Okay, we'll get started. Can you guys turn your webcams, everyone? Yeah, here we are with oh my god, not today. Whoa, whoa, okay. 1 second to read this. Yeah, we're done with complex numbers. You can cheer about that. I just had to show you one thing which we didn't discuss about complex numbers. It's just that uh, this being a very complicated topic, is there any quiz today? I've not yet decided. Depends on my mood. Okay, if I'm happy, you'll have a quiz. Make me sad, and you won't have a quiz. Okay, just kidding. Don't do that. Can I send the breakthrough? You guys can do it. Yeah. You might not have a quiz today, most likely. It's currently stands at around 75% chance that you won't have a quiz. There's a 25% chance still that you might have a quiz. So yeah, let's see. Uh, yeah, I know it's a good weekend. Everybody turn on the webcams. Okay. Is there workbook for complex numbers? 1 second. Uh, complex numbers, no. I think your quizzes, I told you, right? Your quizzes are the most dominant thing there, not the DPP. There's a DPP which has been uploaded, I told you guys. But yeah, cool. With that being said, I just need to discuss some quirks, which found this meme on Reddit some days back. Uh, Interesting. I think weird. I don't know how to interpret it, but something. Quiz will let you know. There's a chance, some chance that there might be a quiz. Where is the DPP? The DPP is on Google Classroom. It's uploaded to Google Classroom. You can check it out on your own. Okay, if you're interested. Okay. Okay, cool, Shashank. Yeah. Now, listen to this part. I need to discuss this part. I didn't talk about this. I just told you about. Yeah, it cannot. Is the DPP compulsory? No, you guys don't have to submit that DPP. Chill. You can take it like a menu in a restaurant. Okay, a restaurant or restaurant, whatever. Just take that DPP like that. Pick problems that you want, solve it if you want. Okay, others don't come to the restaurant at all. I'll be happy also. Okay, that's just there if you want. Okay, that DPP was prepared for PU students ranging from what do you say, uh, NCRT up till J advanced problem sets. It's a very complicated problem set with a lot of interesting problems. One of my favorite problems in that is this one. You guys might know about this problem. Oh my god. 1 second. I do not know the values. It doesn't matter. Okay, wait. You guys might know about this one because the other batch, when I did it, they knew about this problem. They really knew about this problem. Okay. It's the same. It's the same, Mithil. It's the same PPT. The classroom which you have there is the same one. 1 second. I'll just need to find this problem. Yeah, got it. Okay, tada, I got it. 172. Yeah, got it. So you have the coordinates. I think you know about this problem. Coordinate A which is 1, 7, and there's a second coordinate. I don't know whether you guys know about this, 8, 2. Okay, this is B. Okay, this line joining them forms the diagonal of a square. You guys know about this probably, and you have to find the coordinates of C and D, the coordinates of C and D. You guys know about this problem? How many of you know about it? You've been given just these 2 points, and you guys have to figure out what are the diagonals C and D. Yeah. No, I'm not teaching complex numbers now, but I'm just saying, just the gist of it. I'm summarizing certain things. It's a very famous problem. You guys can solve it for fun if you're interested. It's basically, this problem can be solved in one line in complex numbers. When compared to coordinate geometry, you might require one full page. Okay. Basically, these 2 points A and B, the line joining them is a diagonal of a square. Okay. Oh my God. Diagonal. Okay, of a square. So you guys have to figure out what is the coordinates of C and D, other 2 points that make the square. Okay, that's the question. Yeah, it's not common sense. It's not easy to figure out. Okay, the answer lies in using coordinate geometry you can figure it out, but that's going to be lengthy. With complex numbers you can do it in one line. Okay, and morally this is what he's here. This is what complex bashing sounds like. Okay, where you take a simple difficult problem in coordinate geometry and solve it in one line in complex numbers. So this has some serious applications. I'll come to it. Anyways, no, I don't think so. I don't think those are the points. One second, wait. C and D are, oh my God, one second. One second, I'm just trying to figure out the answer. Come on. 7, 8, 10. Yeah, kind of right. No, you guys are wrong. Okay, anyways, with that being said, just figure this part for now, okay, if you're interested. Now, leaving this problem aside, I just need to discuss about I power I. Now, this is something I just didn't discuss. You guys know that I is nothing but e power I pi by 2. Fine with this, you guys? It's not obvious, No. Some of you are saying it's 1, 2, 7, 8. Yes, you guys are right, but how would you solve it is a bigger question for me. How would you go about solving it? Okay, for that. Do you guys agree with this? Can I get a yes or no? Do you guys also agree that 180 degrees gives you -1? E power I pi. Fine with this, right? 180 degrees, pi is 180 degrees. It gives you -1. Agree with this? Can I get a yes or no on both of them? Okay, if you agree with this, this right here is called E equals mc square of mathematics. E power I pi minus plus 1 is equal to 0. This is called the E equals mc square of mathematics. The reason is it contains E, it contains pi, it contains I, and wow, it contains 1. Okay, some of the favorite numbers in mathematics. So this is considered to be the E equals mc square of mathematics. It is a square, so it must be a straight line and must be at any point. No. That doesn't work. Parallel lines concept won't work here. You guys will miss out on slopes and many other ideas. But I want a one-line answer. I want to show you that with complex numbers, the answer is one line for that problem. And solve it is one line. And whoever solves this using that method is the one who truly knows geometry. Okay. In fact, we can say you were taught by probably Srikanth. Okay. Unless you know that, you wouldn't be able to solve that way, using those methods. Because you'll start doing translations and transformations and rotations. You start using those ideas in geometry rather than thinking in terms of parallel lines or slopes and stuff like that, because that's stupid. I told you last time. So slope is a stupid idea. You don't have to think in those terms always. Yeah. I won't tell you how. My point is, I told you something last class. Remember 2 classes back? Tell students something in the class. Don't reveal it till the end of the class. Keep them waiting. Okay. That's the point. Okay. So you get them hooked onto something. Now, with this being said, if I is this, then what will be I power I? Some of you are going to Google, you won't be able to figure it out. Sorry. Some problems are so hard that you won't find them on Google. I power I. What do you think I power I is then? Can I substitute in place of I, e power I pi by 2 to the power I? Everybody fine with this? I just plugged in wherever there was an I, e power I pi by, but this I didn't remove. But then, when I multiply this I inside, do you agree this becomes e power I square sorry, I square pi by 2. Yeah. I square pi by 2, find this. Yeah, this becomes e power minus pi by 2. Yeah, but now I have a question for you guys, because I square is minus 1. Okay. But look this up on the internet or try finding out in a calculator. This value is a real number. This value is a number. Normal number, real number. Think, I don't know, just calculate. It comes up to 0.203 something. E power 2.0.2, yeah, 207. Somebody send me the actual value. 2.788 something. So yeah, as simple as that. If you knew this formula, it's as simple as that. Do you see the power of this formula? E power pi by 2. It lets you do certain things which you wouldn't be able to do with the normal this thing. Okay, normal this I to the power I, you wouldn't be able to solve this without using any, yeah, kind of rotations, not exact rotations. No, we're not done. Again, if you take this value and take e power again to the power I, the whole thing to the power I, what do you think will happen? Again, you get e power minus pi by 2, the whole to the power I, right? Yeah, that will give you e power minus I pi by 2. But minus I pi by 2, minus 90, we know it's minus I. Yeah, right? So if, again, this thing, if you take and raise it to the power I, so I power I is minus I. That's why I said that. Because when you take e power minus pi by 2 and raise it to the power I, this becomes I pi by 2. But you know, minus pi by 2 is minus I. Fine, guys. I'm just saying it just does this. Okay, just saying. I'm telling you the advantage of it. Okay. One more advantage that I didn't discuss. What about this? 1 plus I, the whole cube. Whole cube. How much is this? How many of you know this? To the power 4. Or to the power 4. Let's do to the power 4. What is this? I'm not going to teach translations and reflections because you guys are not ready for it right now. It's a J advanced topic. Very, very difficult. Previous one, I just took the, look. I power I to the whole power I is this. I power I is nothing but e power minus pi by 2, which we calculated from the previous problem. So what I did was I just took this to the power I again. So that gave me, yeah. Okay, cool. So if you guys got that part, no, you guys got this part, e power minus pi by 2 to the power. Yeah, fine with this. Oh, this is I power I. I power I we have calculated, right? I power I we calculated here. Oh, come on, we calculated it here. This is I power. This is I power I. 4i square. Yeah, kind of true. Yeah. How do you get 0.7? Just raise e power something. Try it. E power minus 2.7 in your calculator. Type 2.7 into to the power minus pi by 2. Pi by 2 should be somewhere around 3.14 by 2, 1.5 something. Try doing this. You'll be able to get it. How minus I? This is simple. This becomes e power I times minus pi by 2. What is minus pi by 2? Argument. What complex number is at a distance of 1, but as an argument of minus pi by 2, minus 90. Yeah, this should be in radians. The rule is this should be in radians. You should keep it in radians. Yeah, minus I. So that's how we get minus I. Okay. So with that being said, just saying this makes more sense. Now, some of you, what did you guys do here? How many of you, how did you solve this problem? All of you raised it, right? Most of you. Look, a faster strategy, I'll show you a faster strategy. This can be written as root 2 into e power I pi by 4. Agree with that? Agree with that? 1 plus I can be written that way. Oh, not minus 90. It has to be radian. No. I took it as I power I, which means first you do it this way. That's how I thought about it, and not the other way. You can try it the other way also. Yeah. Now here's the thing: exponents are not commutative. Keithan, just saying. Okay. You guys are right, but hope you agree with this. Can I get yes or no? Root is coming from the 1 plus 1, 1 square plus 1 square. Length of it, magnitude. Okay. Length is 1 square plus 1 square. Now, do you agree? What is root to the whole to the power 4? Root to the whole power 4. And this becomes e power I pi by 4 into 4. I agree with this? Can I get a yes or no? But that becomes, this becomes, look, root 2 squared is 2. That when you square again, you get 4. Agree with that? Root 2 to the power 4 is 4. Agree with this? Can I get a yes or no? Pi by 4 because of the angle it makes, 45 degrees. It makes an angle of 45 degrees perfectly. Okay, with the angle of 45 degrees with the x-axis, 1 plus I. You can verify that if you want. Okay. How root 2 the length? 1 and this length is 1. So this should be root 2 of 1 plus I. The distance that it is from this. Okay. Now, you might have to take my word for it here. This gives you 4 here. This gives you 4. But this is nothing but 4 and 4 gets cancelled. You're left with just e power I pi. But what is e power I pi? Minus 1, right? That's minus 1. So you land up with just minus 4. Yeah. Okay, you land up with minus 4. My point is, when you have to do, okay, this is one thing. This is a well-known secret of complex numbers. If you are doing squaring or multiplication, use polar form. If you are doing addition or subtraction, a problem involves addition and subtraction, use this form. What is that? Use this thing. What is that? The rectangular form. Okay, so depending on the situation, if you're doing multiplication, it's polar. If it's addition, it's what do you say? Use this thing. What is that? That's a trick. That's a trick to solving complex number problems. And this is by far the hardest problem topic in first PUC. I'm not kidding. Everybody's uncomfortable with this. It's very hard to get it in first shot. Most people need 2 revisions, 3 revisions. I personally hated it when I first learned it. A rectangular form is a plus ib. A plus ib. Yeah, you get a different answer, Keithan. Yes, I know that. What we mean by I power I here is I power, you do first I power I, then raise it to the power I. That's what we do every single time here. Because I know they give you different answers. If you do I power I, that's a different thing. 2 cube is not the same as 2 cube is not the same as 3 square. Okay, they're 2 different numbers. Yeah. Now, with that being said, listen up. We just didn't cover one more thing. That is talking about this part, right? You guys want me to dwell into this? Okay. Now, this is correct. Okay, this is correct. There's nothing wrong with this. The point is, how can I put it? Yeah, if you're dealing with the imaginary sides and if you're dealing with this length like this, and this makes sense then, if you're going to use general formulas. Okay. This is fine. Look, if you're going to measure sides using imaginary numbers and you're going to measure the other one using some real number, you are going to get nonsensical answers because this third side could be fine. I could do mathematics like this. Look, you guys know this, right? Angles in a triangle did not add up to 180. You know that part, right? Do they always add up to 180? Angles in a triangle? Come on. Most of you are like, that's the tenet of what you have studied. Come on, it's in our Bible. We have studied it for years. How dare you throw it away? Like, this is 60, this is 30. This should be, whatever it is, this should be 90 degrees. You know this. Yeah. My point is non-Euclidean geometry. Yes. It need not be the case. Okay. That need not be the case. So it need not add up to 90 degrees. So it will be very specific of where it adds up to 90 degrees. On the Earth, if you do it, you won't get it. So on the planet Earth, and this is the worst shape of the Earth ever drawn, it's looking at a potato, but irrespective of what that being said, if you try drawing a triangle on the Earth, a straight like triangle like this, you will see the angles will be greater, whatever you try. Okay, on the Earth, on the surface of the Earth, if you draw a triangle. Yeah. So yeah, cool. Yeah, no offense to all the potatoes. Fine. I'm missing a lot of messages, guys. There's a stream of messages coming in. Okay, 1 second. Can I prove it? Just read about this called Riemann geometry. Okay, what you're studying is, or study something called non-Euclidean geometry. So, non-Euclidean. What you're studying is Euclidean geometry. So, on curved surfaces, it doesn't work. Yeah, Riemannian, whatever. I don't care about his spelling because he's dead anyways. He won't shoot me. Okay. So, anyways, with that being said, Yeah, it can be small. Depending on the curvature, the angles can be less or greater or whatever. In fact, there is a square, a five-sided square. There was this idea called a five-sided. Check out this number file video if you're interested. There's a five-sided square concept called five-sided square. Just look into it, okay, if you're interested. It's playing around with the definition. So then distance between I and 1 on the arrogant plane is 0. Look, uh, it depends on the definition of distance. Okay, I'll come to this. Okay, glad you guys asked that question. Does it mean the distance between I and 1 on the complex plane is 0? I'll come to this. Okay, so my point is distance formula doesn't work always, what you've studied. Okay, that also should be thrown out of the window. Okay, that always doesn't work. So my point is, I think my point was this: those of you keep asking me for formulas in the future will get thrown stones at you. By the way, if you're interested in formulas, this is a formula for 8. If you want to remember the number 8 in the future, this is a formula for it. Okay, please memorize this. It'll come really handy in the exam hall whenever you forget the number 8. Okay, please use this to calculate the value of 8. Okay, fine with that? Please, please, please. It's a beautiful formula, always works. I can assure you, it always works. Okay, just keep using it. Okay. Uh, anyways, yeah, it'll help you a lot. Yeah, that's sarcasm, of course. I'm bad at, I know. Yeah. So my point is, yeah. So just saying, formulas are not everything. Okay, your formulas that you study today won't work on a problem tomorrow. You need to understand the physics of it or the mathematics of it. Okay. So yeah, this is a formula for 8 if you're interested. Yeah, Shashank is like 80 by 10 would be a better approximation. I know, but this sounds better. I love this. Okay, my favorite approximation for it. I like memorizing it. I forget it often, you know. I forget it often. Yeah. So I just memorize this formula and go to the exam hall. Yeah. Pythagoras theorem, Satvik, I'll come. It doesn't work like that. Okay. Now, with that being said, I just need to add something which I didn't discuss. That is, you guys remember this formula? Again, I'm thinking of speaking of formulas, e power I theta is nothing but cos theta plus I sin theta. I just told you about it. Remember this? Kind of remember this? Can I get a yes or no? Yeah, if you do e power minus I theta for some reason, you get cos theta minus I sin theta. Now, why this happens is because if you do minus theta, cos theta remains the same. Cos of minus theta is cos theta. Is that fine? This you know, right? Trigonometry. Sine of minus theta, though, gives you minus sine theta. Do you remember this kind of? Just saying, just saying. Or guys, I want to look at it this way. What I'll do is I'll take conjugate on both sides. I'll take conjugate on both sides. What happens to I here? It becomes minus I. Agree with this? What about the I here? It becomes minus I. Got the logic how I got the second formula? I just took conjugate on both sides. Now do you see the application of conjugation? It's much more simpler. Life is much more simpler. I'm just taking conjugate on both sides in the top equation. Can I get a yes or no from everyone? Wherever there's an I, I'm doing a minus I. That's all. It remains the same. Okay. If everybody got this part, what happens if I add them both together? Yeah, every time if you have to do it on both sides, you have to do it on both sides. Conjugation has to be done on both sides if you're doing it properly. Yeah. Life is never okay. Got it. What do you get? Tell me if you add both of them. You get e power I theta plus e power minus I theta is equal to 2 cos theta. Agree with that? One second. Yeah, it's just I getting multiplied to sine theta. That's all. Okay. Yeah. Now listen to this part. This is something not so advanced. I'll just divide by 2 on both sides. Do you agree with this? Cos theta is that. Congrats, you have a formula for cos theta. Ta-da! You love this formula more than the previous formulas that you studied in your life? I don't know, but it has complex numbers. So ta-da! Enjoy. Okay, so you have a formula for cos theta. Similarly, you can get a formula for sine theta if you struggle a little bit. You get e power I theta minus e power minus I theta divided by 2i. That will be sine theta. You can thank me later for complicating already something that you already knew. Okay, is this fine? Just saying, I just added them. That's all. I just added these two equations and got cos. Similarly, if you subtract, then you get sine theta. Is this fine? It is not part of the syllabus. I'm just doing some additional stuff here, just to give you some perspectives on things. Yeah. 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 It will be useful in the future. You'll know it. What about complex calculus of I'm getting there. I'm getting there. I'm just getting there. Okay. If you guys got it, now I'll tell you why this is so powerful. Okay. This is a game changer. This thing here is a game changer. I'm not kidding. Now tell me what is cos pi by 2. You guys know that. E power I pi by 2 minus e power minus I pi by 2. Agree with this? Oh, plus minus I by 2. Agree with this? Using the formula. Okay, what is I for I pi by 2? I, right? This is minus I by 2. Tada, 0. You guys knew this already. Cos pi by 2 is 0. You can thank me later. Formula works. Fine with this? Got the logic? I don't know. Some of you got this or not. E power I pi by 2 is I told you earlier. And e power minus I pi by 2 is minus I. So I minus I. Tada, works. Okay, now you might say, okay, if that works, does this work for I, cos I? What about cos I? Now you can start playing some interesting games. What are cos I now? You get I square here, minus I square, and you get something like, I don't know, e power minus 1 plus e power plus 1. Agree with that? This becomes, got it, in place of theta, I'm plugging in I, that's all. Yeah. Can anyone calculate for me what will this be? 1 by e plus 1 by e by 2, something like that. 2.78 plus something by 2, something like this. I don't know, some value. This will be, by the way, e is 2.78, something 78 or something. And 1 by e will be reciprocal of that. You have to add them and then divide by 2. What is that value? Can anyone send me the value? I just plugged in around 1.5. Have you ever seen cos theta give you 1.5? You get 1.5, yeah, you're right. Have you seen cos theta anywhere giving you 1.5 something, 1.543? Yeah. Greater than 1, right? Yeah, so my point is complex values, when you plug into theta, can give you something larger than, greater than 1 or less than 1. Just telling you, okay, is that fine? Yeah, in the complex world, these things are defined. So sine inverse of 2 is defined. Okay, sine inverse of 2, sine inverse of what? Okay, by the way, tell me, what is sine inverse of 1.543? What is sine inverse of 1.543? We just calculated. Sorry, cos inverse. I, right? It's I. So my point is that that's it. I'm just saying whatever you think was undefined is finally defined thanks to this formula. Why this formula is a game changer? There's one more reason, is integration. Have you heard of integration? Complicated integration and stuff like that. Yeah, that's where this formula makes it so simple. Sine integrals and all, very complicated integrals. You guys are not familiar with integration, so I'm not going to dwell on that. But yeah, my integral looks ugly. I don't know how to write. It's a S standing for sum. That's why I wrote it that way. But if you're going to write it in a neat way, Picasso, come on, Picasso. Yeah, there you go. Yes, good. Yeah, that's A to B integral. Yeah, come on, it can look good. Yeah, it looks good. Yeah. So my point is some dx. Giving ugly again. So it just works. Which game are we playing, by the way? It's a game called algebra and solving the problems and stuff like that. Yeah. So I'm just saying, done. Tada. That ends complex numbers, guys. Done. Yeah. Sorry about the lag. We are done. I know it's an insult to Picasso. Now, we are starting coordinate geometry. We're done with complex numbers. That was just a gist of it. If you want, okay, please go and Google, do what you want, learn about it more. There's a lot of interesting things there. I'm just giving just a little bit here and there. Okay. Pratyusha is like PPT. Chapter is over, PPT. Okay, fine. You'll get it. That it's not like PPT, it's PPTSR. Okay. And it's spelled P for some reason. I don't know. Okay. Anyways, with that being said, I'll send it. Okay. Yeah, people, there are more slides. I know. I just skipped a lot of things for you guys. You guys didn't need it. Okay. I just did something overboard here a little bit, which you guys don't need right now. But I think that was the point of it, the gist of it. I just want to give you something more here. Okay. Okay, cool. Is it required for the test? Which test? Okay, you'll know soon, don't worry. Don't remove any slides. I won't. You just put it there. How come Murali isn't here? I don't know. We haven't figured out yet. Yeah. Let's see. Please safe. He'll be somewhere. Okay. We'll just contact him later. Basic nomenclature or namakarna, I call it. Now, you guys know the x-axis. Can you clap for x-axis, guys? Woo! Yeah. There you go. We have x-axis. Yeah. Cheers. That's called coordinate, beginning of coordinate geometry. Ta-da! And there you go. That's the y-axis. Ta-da! Yeah. So welcome y-axis and x-axis. Now you might think, are you drunk? Why are they slanted like this? Yeah. Oh, you forgot the arrow on x. Is there an arrow on it? It's like this. Oh, okay, fine. By the way, it's fine. Thank you for that. Okay, done, fixed. I know screen is lagging by a little bit, but I think it's fine. Is this fine, guys? Happy with the x-axis and the y-axis? Are you guys happy with them? Okay, ta-da, they're on the screen, and we add up something now. That is the origin, guys. That's the O. That's the origin. Yeah, welcome. Now, next part, that point right there, that's called P. Okay, that's a point. Why P? Because that's usually what we call points. Okay, not after me. Okay, now that line is called the abscissa. I don't know why it's called that, but it's called the abscissa. It's a line which is parallel to the x-axis. Fine with that? No, it's in flat 2D. There's nothing happening. It's happening in 2D. I know you have probably that feeling that maybe it's out of the world, because they're slanted slightly. Okay, fine with this. That's called the abscissa. Have you heard of abscissa and ordinate before? Yeah. Okay. I don't know why they're called so, but we are welcoming these into the family. Okay. So by the way, that's the x-axis and that's the y-axis. Okay. Fun fact: do the angles have to be perpendicular? Do the axes have to be perpendicular? Like seriously? No. Okay. That's a fun fact. So my point was, I am preparing for the class and I've been asked to teach distance formula. And I'm thinking to myself, these kids know everything. What do they not know? Okay, and tada, here we go. You guys did not know this. So we continue. Now, axis can be slant. Okay, first of all. Scientists have the privilege to name things and discover. Why do they give boring names? I don't know. I am planning to give names like Banggood and all in the future. So God forbid I become a scientist. Okay. Anyways, how can they be slant? I'll come to that. You see, mathematics is like you do your stuff. See, the thing about physics is you can't cook up your own stuff. You're like, get out. Okay. You don't start saying that there is some sort of different form of fifth force and some energy and stuff like that. In mathematics, we can start with the word assume and go doing stupid things we want. Start with the word assume. Okay. So just saying. Okay. Yeah. Anyways. With that being said, that angle can be anything theta. Okay, you can start with theta. In fact, in PUC, when we start first, we start with theta. We start with a random angle. In fact, a JEE advanced, JEE main and JEE advanced deals with any angles here. Okay, we just don't go with the, yeah, nice. Mandelbrot, you just said their color points. Yeah, I know. Assume Prajwal has a happy life. Thank you. Physics is full of assumptions. You only said, yeah, exactly. There are a lot of assumptions there, but yeah, you get the point. If we study the actual way of doing it, it gets much complicated. Now, usually people like 90 degrees. People love 90 degrees. It may not be 90 degrees always. Okay. But we love it with 90 degrees. I have a question for you guys. This is fun. Assume that the earth is flat now. Okay, I know. You can start assuming and drive conclusions, but that will not be factual. Okay. You can, in mathematics, you can assume that the triangle is having angles greater than 180. Okay, and arrive at a contradiction. I bet the flat earthers will arrive at a contradiction if they assume that. Okay, just saying, if they take facts into account. Okay, so with that being said, listen to this. Why is it called square units? Why is area measured in square units? Can't we measure them in triangle units? Why not circle units for area? Why is it always square units? It sounds stupid, right? Because it's a square? Have you ever asked yourself why is it square units of all the things in the world? Could have been anything else. Yeah, we just got used to it. In fact, look, you can write everything in circle units. In fact, I can write area in circle units. But the problem is if I want to fill a space with circles, tada, you'll have gaps in between. This is the worst diagram for circles, but you get the point. If you fill a plane with circles, you'll have gaps in between. How will you fill the space? Now you might ask, well, why not use a rectangle units and triangle units? Triangles fill the space, right? Yes, it works. Okay, now I'll tell you why it won't. It's the idea is square was for some reason Pythagoras was responsible for this. Pythagoras. Okay, it made kind of more sense to define things this way. Rectangular things make more sense for us, like this angle of 90 degrees and stuff like that. We just stuck to it. You might ask, why did we use 10 symbols? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, sorry, 0. Why did we use only these symbols? Can't we have cooked up a symbol called, I don't know, ha, letter ha, I don't know, ka, and stuff like that? We could have gone with it, right? And had it like next number is ka 0, ka 1, ka 2. It could have worked out. I have done mathematics in base 12 system before. Not kidding. Yeah. This is not nonsense. It's not nonsense. It works, by the way. In fact, computers use hexadecimal. You know that, right? Computers use hexadecimal. Computers don't care about you guys. I know there's a small lag. I don't know why. Computers use hexadecimal. They use 16 symbols. That's why the URL of a YouTube video is V is equal to some F K 1 0. That's a hexadecimal number at the top. Okay, it's a hexadecimal. It's a different. It uses a completely different. In fact, if you want to become a good at computer science, you need to learn those things. Okay, you need to use binaries, yeah, and stuff like that. Yeah, your Kannada handwriting is good. Thank you. Nobody has ever said that. I hope that's not sarcasm now. Okay. Anyways, with that being said, yeah, if anybody doesn't know Kannada, I'm sorry. Is origin the center of the plane? Yeah. Is there a class tomorrow? I don't know. Do you know Kannada? Gottundu. ಸ್ವಲ್ಪ. It's horrible if you listen to it too much. Okay, just take it in small amounts. So yeah. Anyways, okay. Yeah. Anyways, with that being said, circle units is possible. Okay, circle units is possible. Triangle units possible. In fact, hexagon units is better. I would prefer hexagon units. And I would prefer base 12 system because it divides with many other numbers before it. 10 doesn't divide by many numbers before it as compared to 12. Okay. Yeah. Are you like Chatur from Uganda? Probably. I could be the Chatur of Kannada. Yeah. Chatur Ramalingam, right? Something like that. Yeah. Python unta. Permary tomorrow, I don't know. I have to speak with the office. I'll see if they've scheduled a class. If they've scheduled it, they want. Why do you hate the imperial system? Because US is the imperial system is, yeah, US is the only one using it. That's why we hate it. Do you know Konkani? Ille gotta. I mean, not the GSP Konkani, this Konkani, this side Konkani. Anyways, is there a coding class tomorrow? I've not decided yet. Okay. Anyways, with that being said, let's continue on. It's base 12. What is base 12? Imperial system. Yeah. Oh, I didn't know that. I'm not a Konkana. Okay, the same. Okay, anyways, guys, we'll continue the class. Listen up. So if you have a system like this, you can fill a space with triangle and have triangle units. That's fine. Okay, square is something we got comfortable with. Anyways, with that being said, we'll go ahead. 1 second. This is 90 degrees. Next class, you will fully speak in Kannada. No, I won't try that. It'll be a disaster. Okay, Namakarana, guys. Come on, cheers, everybody. What is this point called? Come on. Do you agree it's 1,1? Tell me yes or no. That's enough. Yeah, happy, right? Oh my god, it's loading now. Sorry. It's loading now. Which point? It's loaded now. I'm sorry. I bet my sister is using the house Wi-Fi in the other room, and that's why it's lagging. I can't yell at her because she'll yell back. Now, wait a second. I need to switch to something local like Geo. Let's see. 1 second. 1 second, guys. Wait. Guys, by the way, meanwhile, while you're at it, saw the next problem. What is this? 3,2. Yeah. While you're at it, solve it. Yeah, that's 3,2. Is that fine, guys? I have not yet switched to the better internet, so just give me a second. Yeah, you guys know this, right? Are you scared of your sister? Am I? I don't know. I shouldn't be saying it loudly. She shouldn't hear. That's all. Okay. Anyways, with that being said, let's go ahead. Okay. This is 2, 1.5, guys. Congratulations. You guys know it. Elder, younger, younger. Yeah. Anyways, with that being said, this is 5, minus 3. Is that fine, guys? Fine with that? Yeah. Since the plane is infinite large, I can pretty sure call any point as the origin. No. You start with the point as the origin. Is that fine? Oh. This here is wrong. This is wrong. Yeah, not wrong. Wrong. Yeah. How much is it? Tell me. Come on. Correct it. It's minus 5, minus 3. Okay, do not mess that up. It's both negative axes. You guys know this, right? I can go ahead faster. Yeah, with this. This one. Oh, by the way, I think of this as an address. Okay, and addresses can keep changing. It's up to you. Okay. If I shift this entire axis away, this point will no longer be 2, minus 2. Agree with that? This point can be something else if I move this axis further. If I move the axis here, or if I move the axis here, it will be a different point. Got the logic? That need not be 2, 2 itself, depending on where I position my axis. Wait, 1 of you at a time. Why can't x and y axis intersect at more than one point except the origin? They can if the angle between them is 0. Only then. Okay, they can intersect properly, nicely. By the way, you can have bent axis, guys, like this. This is y, this is x. For the first time in my life, I've drawn a proper axis. Okay, because whatever I draw is correct. That's why. Yeah, so they need not be straight lines also. Okay, the axis need not be straight all the time. That also is there. You can. Is somebody playing violin in your house? No, you have a problem. You're dreaming. Yeah, in your head it's playing. They will intersect on the other side of the world. Maybe, I don't know. Okay, yeah. With that being said, distance formula. You guys know distance formula? Can you guys cheer for distance formula? Yeah, awesome. Okay, good. So what is the distance between these 2 points? Come on, please. Come on, guys, please. Come on, do it. It's easy. It's very, very easy. What's the distance between those 2 points? Oh, come on. Yeah, Medansh, you guys are right. Now you're right. Yes. Sumedh, you're right. Satvik, you're right. Yeah, these sessions are done just to remind you the formula if you've forgotten. That's why. Nihad, you're right. No, this is okay. For those of you who weren't in CFL last year and do not know about it, it's just this. Subtract the x coordinates, subtract the y coordinates, square them, add them, and take a square root on them. Is that fine? Just that. That's the distance formula. Okay, so in this case, what are the x coordinates that are subtract? 1 and 4. You have to subtract 1 and 4. That gives you 3. And then you're supposed to subtract 3 and minus 3 and 1. Okay, that gives you exactly 3 square plus 4 square, giving you a total result of how much? Yeah, it's Pythagorean theorem in disguise. Sir, in observer 40, but okay, can you inform the office actually about the Schoology thing and the marks issues? The office is handling that. Can you contact the office regarding that? There's some issues with that damn thing for some reason. There's a grading period issue, and then there is some issues on Schoology. We need to figure that out. Okay, yeah. So with that being said, fine with this. This length is 5. You got y. Got the logic? Hey, by the way, you guys have received your optics marks, right? Second test you're not receiving. Second test is the issue, right? First test is done for you guys. I'm pretty sure there's no issue there. Yeah. Okay. Guys, happy with the distance formula? Everybody fine? Works? Yeah. 50 out of instead of 43. Okay. I'll correct that. I'll inform the office. Then that's my responsibility. I'll inform the office. Okay. They did not know it was 43. Okay. Yeah. Okay. Guys. Fine with this? They just transferred it directly from my document to this thing. They didn't know it was 43. Yeah. Okay. Fine with this? Can I get a yes or no? Everyone? Just saying. Okay, that's distance formula. Whoever wasn't in CFL last year, did you guys get this? I'm just worried about them right now. That's a priority. Top on priority. Okay, you just subtract them. Okay. Now a fun fact. This is the distance formula. Again, I'm going to ask you the fun question. Does it have to be this itself always? I always keep asking this question. Does it have to be this? Does it have to be this always? No, I can cook up my own formulas for distances. Fun fact. Okay. Again, be a mathematician, cook up your own things. Okay, it works. This is a well-known formula, distance formula. Okay, it's basically just subtract the axis and add them. It works. It's a beautiful formula, nice one. Everybody loves this. Okay, in this case, you don't have to do squaring and all. Yeah. So you cook up it. Yeah, I can be a better chef. I get it. So you, by the way, this is what mathematicians are, guys. This is what a job of a mathematician is. Okay, you just come up with stuff in your head like, oh, this works here well. But do you think this has some use? How many of you think this has some use? This distance formula. This distance formula is stupid, but this one has a real use. As great, I bet this formula is more useful than this distance formula. Top one. Can anyone guess? Here's your hint. It's famously called the taxi cab metric. Metric is usually the word used for distance, so it's called the taxi cab metric. This is called a Riemann metric, used in Einstein's relativity and many other things. Yeah, I know, Sakshi. I'll look into it. Okay, I'll just go through it. It was brought to my attention today, so I'll look into it. Yeah, you can do x2 minus x1 or y2 minus y1, up to you guys. But my point is, this is very well. Where do you think they've used it? Like, any guess? This is your hint. It's called taxi cab metric. In fact, Uber uses it. Okay, Uber uses it. Everybody uses this distance formula. They don't use this distance formula to calculate the shortest distance. Okay, I have a question. If let's say you book a Uber and you want to, I don't know whether you've ever booked a Uber, but if you're booked a Uber and you want to go from, give me some locations, guys. Let's say from your house to the Kankanadi Mental Hospital. Okay. Now let's just say, why? Don't ask me. Just going to those locations. Now, in that case, do you think the shortest distance is calculated directly? Do you think you'll apply the direct formula like this? Like this is one location, one location. Are you flying through the air, guys? Are you guys flying through the air? So does that distance formula work there? It doesn't work. That's not the shortest distance. The shortest distance is a much more complicated thing. You might have to take roads, zigzag roads like this. It need not be x1 minus x2. It can be x2 minus x1 also. I'm just saying. Okay. In this case. Now, in that case, this formula makes more sense. I'll tell you why. If you have this a system x and y axis, you know, in the US and all, they have this thing, right? It was from pixels. Do you know in US you have this block system? They have blocks, and oh, I know it's not a mental hospital. I'm just specifically saying to the ward of the this thing. Kankanadi is it's Muller's guys. Yeah. Anyways, yeah, it's not. It's yeah. It has a better branch of yeah. I go there often. I mean, not to the ward. I go to some other place there when I go to that hospital. Okay. Yeah. With that being said, I had to go once, guys, once or twice. Okay. Yeah. So my question is, if you want to go, you know the block system in America, right? So if you want to go from two locations, let's say 4,3 to this thing in a grid-like system, the shortest distance will be this. Agree with that? Something like this. If it is 3,3, if it's 3,3, it can't be the straight line between them. Yeah. Now, Father Muller is referred as a mental hospital often because it was used to be the only hospital that maintained it really well, balanced it back in the day. It is one of the oldest hospitals of Mangalore, and yeah, so that's the reason, I guess. Yeah. Now, do you agree? There is permutation combination, but do you agree the length is 1 plus 1 plus 1 plus 1? It's basically all the x lengths 1, 2, 3, 4 plus 1, 2, 3, 4. Agree with that? It's just the sum of all the x lengths plus the y lengths, all of them. Yeah, don't ignore mental health. Mental health matters. I am sorry. Okay, just saying. Okay. Oh my God. Yeah. Anyways, yeah. Okay. Anyways, with that being said, do you agree it's just x lengths plus y lengths? You just add them, you don't square them. Do you see that? In this case, you don't square them, you just add them. You add the x lengths, 1 plus 1 plus 1 plus 1, and 1 plus 1 plus 1 plus 1. Just add them. Yeah. So, oh, my point is basically, if you want the shortest distance between 3,3 and 0, 0, 0, it won't be a straight line. It'll be a zigzag line like this. If it is a block system, if it's a road system like that. Okay, and it doesn't work. This is 4,3. 1, 2, 3, 4. 1, 2, 3. Yeah, it's 4,3. Sorry, distance between 4,3. And it's going to be, you need to be adding 3 lengths. That's it. 1, 2, 3. So it just becomes difference in x, difference in y. You just add them. In fact, there's a modulus here, which I've forgotten, but you get the point. Okay. So it just becomes the sum of the lengths. It's your distance formula. This formula doesn't work. So just adding it. Okay. Why don't you use that in Mangalore or India instead of US? Because in US, it's a very, you can use it in Mysore, not in Mangalore. You know Mysore, like if you go onto the hill there in Mysore, and if you look down on the Mysore city, you know it's how systematic it is. The lines and all. Yeah, at least it has got block system. You can see the streets. There are something called blocks there. Yeah, it's a much more well-planned city than, yeah, Shashank MN, we know that. You're originally from Mysore. Your name has Mysore in it. Okay. It's, yeah, anyways. Okay, so my point is simple. Not that Mangalore is a terrible city. It's just not a well-planned city. Okay. If we, oh, by the way, if Mangalore gets flooded, we are so doomed. There is no proper drainage system also. There is like, yeah. Okay, my name doesn't have, yeah, yours no Shashank MN we are talking about. Yeah, and Shashank right now is taking classes from Mysore, it seems. Okay, good for you. Yeah. Anyways, with that being said, oh, they use it in navigation systems, so those distance formulas don't work. Does block system work or not? I don't know. You need to speak to someone who is a civil engineer. Okay, I really have no idea. Oh, by the way, Kottara Chowki has the worst drainage. That's called the drainage number 1 in Mangalore. It has a name, by the way. It's drainage number 1. It's the main drainage. If that one gets blocked, everything gets blocked. I'm just not kidding. Okay, as like the main. You go to the Mangalore Corporation website, and I collected this data while I was teaching statistics in PUC. Okay, so statistics is a boring topic, so I had to make it fun. So somehow I don't know. So I pulled a lot of data from the Mangalore Corporation website and asked people to guess a lot of things. So there were some fun things which we did. And I happened to realize while teaching that topic that Mangalore has drainage names. Drainages in Mangalore have names. So if you get blocked in some location, they know which one to repair. So that's why. So yeah, flood analysis and stuff like that. Okay, this is the formula in 3 dimensions, guys. For those of you who are asking, this is used in computer graphics everywhere. If you want in 3 dimensions, if you have 3, you guys know about this, right? Fine with this. X, Y, Z. If you have a point in 3 dimensions, a random point. Fine with this. This will never be asked for you guys, but I'm just mentioning. Yeah. How many roads such as form objects when looked from above? I didn't get that, Shashank. V. Okay, just saying. It's using computer graphics. Just elaborate a question, okay? Yeah. So it's using computer graphics a lot. So yeah. But there is one more crazy application. I'll come to that. Now, do you remember this? We calculate the distance between 4,1 and 1,3. Okay. Now, since most of you know distance formula already, I'm going to go a little bit beyond. Now, some of you might find it is hard a little bit. So hold on to your brains. Tell it for the next 2 minutes to listen carefully. Okay. Okay. So now I'm going to do something. Okay. Something more. You remember the distance formula, distance between 2 points, thumbs up, works fine. Ta-da, that happened. Now let's speak about complicated systems where things change a little bit. Okay. So now the question is, do you see the distance is longer between 4,1? Do you agree now 4,1 is not that point anymore? It's a little bit further. Agree with that? Than where it was? Look at the, I'll do the comparison. Tuck, 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 tuck. Yeah, that's for you guys. Okay, how many of you think distance is longer? How many of you think it's shorter? Which one do you think it is? I know there's a huge lag. I'm really sorry about that. I need to switch to, 1 second. Let's switch to a better connection. Hope this works. Yeah, is it better? Can you guys hear me? Okay. You guys don't know. Wait. Same distance. You're saying it's the same distance. Do you think it's the same distance? Don't you think the line is much longer? Now 1,4 is a location of a different address. Do you see that? It's a location of a complete different point now. The address is a different. Address has been changed. Okay, guys, tell me what is it? The locations have changed now. Now 1, 4 and 1, 3 are not in the same locations now. They're in a different locations now. Yeah, Keaton, you know about it. You know about it. I got it. A location of the reference point also has changed. No. Oh, reference point has changed, but reference point has moved slightly. Like very tiny amount. The reference point. This point has moved slightly. This point has moved large amounts, but this point has moved slightly. Okay, guys, got this bit? Can I get a yes or no? That the addresses have changed. Okay, do you agree that 4, 1 no longer points to the same point which was earlier? 4, 1 is completely different now. This address is somewhere else itself. It's like suddenly the address of your house changed or something like that. Something has happened here. Okay. Now, there are applications of this. I'll come to this why later. But here's the thing. Now, this angle, let's say it's 60 degrees. Now, Keaton knows the formula for this directly. For those of you interested, try figuring it out. I'll tell you what's the formula for calculating the distance. Okay. This distance is actually longer. Okay. This distance is actually longer. I'll tell you why. This is the formula used. By the way, 3 and 4, you can apply Pythagoras, but there's a headache now. There is a headache. This is no longer 90 degrees. Agree with that? This is no longer 90 degrees. Yeah. So you land up with this complicated formula for the distance, where you have this x1 minus x2, y2 minus y1, then x2 minus x1, y2 minus y1, then cos times something. It's actually, Shashank also realized. Can you guys see what this is? Can you tell me where's that 120? Most of you know this. Some of you know this. It has been taught to you. You guys know this. Brinton spoke about this. I'm pretty sure he spoke about it. Yeah, what is 120? Secretively, it's hidden here, 120 in this diagram. In general, it's going to be this angle. You need to plug in the angle. Then you got to subtract the distances. Okay, that's the formula. To write it it'll be cumbersome on the page. So, but the idea is it's just you need to get these lengths. Distance x1 minus x2, that is 3, y2 minus y1, then multiply it accordingly. Okay, that's the general formula. Yeah, do you guys remember cosine rule? If the angle between two sides is not 90 degrees, it's 120, then the third side is given by some c square. A square is equal to b square plus c square minus 2bc cos capital A. Yeah, something like this. Remember this? Cosine rule. I think it was mentioned in trigonometry. It's called cosine rule. It's basically never heard. Okay, some of you have not heard about this. Okay. That was not discussed then. Okay. So this is the formula for it, 2bc. By the way, I messed up a little. Can you guys see what I messed up here while writing this formula? I messed up a little bit. Yeah, I haven't multiplied by 2. I forgot to multiply by 2. 2 into 3 into 4. Okay, this will be 24 actually. Is this fine? This will be 24 here, not 12. I didn't correct it. I kept it as it is. Is this fine, guys? I'm just saying, did you guys get the 3 and 4? How many of you have a doubt here with 3 and 4? How I got the 3 and 4? It's just difference in the x coordinates and the y coordinates. Do you guys get the 3 and 4? Everyone got this? Isn't there a 2 in the formula? Yeah, I messed up the 2. That's what I'm trying to say. I messed up a 2. The cos 120 thing is 180 minus 60 degree, whatever this angle is. But this angle is 120. It's going to be that because this is 60. Didn't get that. It's just the difference. It's just the difference in the coordinates, 4 and 1. That gives you 3. Just like earlier distance formula, x2 minus x1. This 3 is x2 minus x1. Similarly, 4 is y2 minus y1. The formula will look ugly if you go on writing x2 minus x1, y2 minus y1, all of that. Yeah. Is it fine? Now fine with this? How I got that x1 minus x2? It's just 4 minus 1. The x parts and y parts. Fine with this? Can I get a yes or no? I'm just adding this here because this is part of SL Loney. It's the most important book in JEE and starts with this itself. Okay, the book for JEE, the top book starts with this equation itself. Yeah. Fine with this? For those of you interested in starting your geometry already, please buy this book called SL Loney. Okay, this is the book used for JEE everywhere around SL Loney. Okay. But then the angles in the triangles are greater than sorry. This can't be Once again, I messed up bad. Wait, this can't be 60. I'm sorry. This is something else. How much could this be? Wait. 30? Yeah, 30 makes sense. Is it 30? Yeah, this could be 30 degrees, I guess. Something like that. Is that fine? That's 30, I guess. Yeah, 30. I messed up. Oh, yeah, this is 30. This is 30. Somewhere around 30. Oh, wait. 1 second. Look, this angle is 60. Okay, this angle is 60. This angle is 60. This angle is, oh, got it. This angle is 60, so this should be 120. Is that fine? Alternate opposite angles. Okay, leave this. This is not 30. This can't be 30. Okay, I had to discover that myself. Okay, got it. 120. Fine. Yeah, so that's how I got it. I thought this would be, I saw it and I was like, okay, should be, this thing is 60. Yeah, now that makes sense. Okay, fine with this, guys. Can I go ahead? Oh, by the way, if you calculate this becomes 24 into 0.5, which is 12. So instead of having 25, we'll have plus some amount 12. 180 minus 60, because you're trying to get this angle 120 here, cosine rule. Why did you all don't realize the axis and the line are parallel? Yeah, that is not obvious all the time. Yeah, this comes up to greater than 5. Agree with this? It was 5 right earlier. Now it comes greater. In fact, this is not correct what I've done. It'll be greater. Okay, this becomes plus 6 again. It gives you something like 37. Root 37 is about 6.66 something. 6.1 or something roughly. Is this fine? I just did something for you additional here. Just gave you the formula for longer distances. That's it. Okay. You guys want a break? No, I think I'll give you 15 minutes. Do you want a break now or do you want it in 15 minutes? Which one do you prefer? Now? Now. The word is now. 5 minutes. Okay, now. Go. Most of you are sending me now. Go for the break. Go for the break. Have that 5 minutes, but 5 minutes. You just have 5 minutes. Come back in 5. Run. 5:30 it is. 5:35 we return. Yeah, I'll take some questions if you have anything while I sip some water. The way you read my messages, I feel like a huge grammar mistake in my life. Yeah, you did. Okay. Vivek, I don't know. What joy? No, Pratisha, that's not happening. Not happening. Okay, what is e power I pi? Yeah, wait. E power I pi will be this one. Okay, that should be e power minus 1. 1 by e, a real number. Okay, cool. Yeah, I know it gets complicated. I understand. Where x is arbitrary. Yeah, it gets. It depends how we group it. By the way, group it smartly. Okay, exponentials you have to be careful. Exponentials are not commutative. 2 cube, I told you, right, is not equal to 3 square. Yeah, I know, Shashank. You're welcome. But 2 power 4 is, yeah, that's a rarity. Okay, that where it works. It did not work all the time. It's not always true. I did not, Pratisha. Let's just say I did not. 2cc in cosine. Yeah, I did. I know. How 2cc in cosine rule? Yeah, that part is really tricky. It's cosine rule. I can't derive cosine rule for you. I'm sorry. It's going to be a very lengthy PPT. Somewhere it is. Uh, but vectors makes it easier if you're interested. Okay. Yeah. Wait. E power I pi is equal to 2. Wait. No. Keep it in radians, by the way. Keep it in radians. 1 second. Yeah, you can go with e power I 90 degree, but then your okay, e power I 90 degree. Sorry. You can go with e power I 90 degrees, but then it won't take it. Do you play GTA or no? No. What makes you think I have time for gaming? Yeah, you talked about multiplying same rotation by 90. How you realize something too? Yeah, now raising usually doesn't behave the same way. For example, okay, I'll show you my simulation. I'd done this long back for PUC. Then I thought it's not worth it for, yeah, here's the thing. It's on my website. I came to know someone is doing video on, yeah, I know, that's Toshit, Pratisha. Okay, so it's in my, 1 second, I'll open it. It's somewhere around. I'd done this. Nidhi is like, if you have time to call us randomly and our question is about Faraday's law of freaking induction, then you can surely have time for that, time for gaming. Yeah, surely. I'll call you guys while I play the game. Okay, that's possible. Uh, Anyways, where is it now? Complex numbers. Yeah, here we go. So complex numbers is here. Oh yeah. That is well done. Yeah, he nailed it on the other side. Keaton some other time. Okay. Here's the thing. Wait, we'll raise the power. So I have actually developed this. This is raised to the power. So what happens is much more common. We'll take I. And perform the action. Let's see. It's under development. So what I'm doing is I'm taking every complex number that I've taken and I'm continuously raising it to the power I. Continuously raising it to the power I. You see, it does a rotation, a 4-point rotation between 4 points. It goes between 4 points. I'm actually taking, I took this original point which I had, which is 1 plus 1i, and I'm raising it to the power. Okay, I'll clear some points. Hopefully I'll be able to add some points. I don't know where's the option. Oh, add point. I'm going to add I, added I. You can see that. And then I'm going to raise to the power I. Okay, so I'm going to perform the action. See, it goes to minus 0.208. Can you see that? E power minus I pi by 2. 0.207. It's somewhere there. I can't zoom in. When I perform the action again, it goes to minus I. When I perform the action again, it goes to something larger. This is e power plus I pi plus pi by 2. That is 4.81 something. And then when you again perform to the power I, it comes back. So it does this weird thing. It's not even a rotation. It shuffles between 4 points, jumps between 4 points. So exponentiation operation, I power I power I power I, and so on, has this pattern. My point is here very simple. Complex numbers, do anything to them, stupid things you can think of. Multiply, raise to the power, take square root on them, do what you want. It'll give you a complex number as an answer. Okay? You can't bully them. Like, you can take a real number and put a square root on it and say, okay, you're dying there. Okay? You can kill a real number by taking a square root on top of it. You can't kill a complex number by doing any of this. No matter how hard you try, he'll give you some value somehow. How do you make all this softwares? Yeah, this was annoying on this. I did it under, yeah, I think I can redo this. I have a system for it. So actually I've been developing an animation system for this, like 3Blue and Brown. If anybody's interested in coding it up, you can learn it on your own. It's on my website right now. It's called Prajwal Souza /template. If you download the code, you'll get it. Yeah, I hope this runs. Yeah, there you go. You can do animations with shapes and whatnot and axes and all this stuff. I think you can zoom in and zoom out. Yeah, yeah, that also feature is there. There's a circle which is increasing and decreasing. It's more like a plugin. Yeah. Is the breakthrough deadline extended? No. Today's the deadline. If you guys want to submit, you can submit. The breakthrough you're talking about the main competition, I don't know. Let's see. I don't think so. I really don't think so. They shifted it from 10th itself because of the coronavirus. So yeah, same deadline, 25th. This remains at 25th itself. Okay, okay. What if someone learned a game? Cool. What if someone takes it, makes it better, posts it on YouTube? Up to them. It's an open source domain, by the way. What I'm doing, my animations and simulations. They're just like Manim. It's yeah. Uh, who are participating from CFAL? I don't know. There's a bunch of you and sending entries should see now. Are you guys done with your 5-minute break? First of all, okay. One thing. So I wanted to ask you, what is the weird thing that's on the top of the CFL building? A viewpoint? What weird thing? I haven't seen it. First of all, I don't know if it's weird. So it will be very specific on what weird means. So it's a broad thing. You know, there many things fit into that definition. Like if I'm standing on top of the CFL building, people can say, okay, what's that weird thing on the top? You know, like that. So a box-like thing. We know we have a dome construction going on for the telescope. Yeah, that's in progress. Just like Aloysius has a dome, CFL is also getting a dome. So that's in progress. See what happens. Yeah. Yeah, can you guys come back? NITK doesn't have one. NITK sucks when it comes to that. Okay, they are terrible at it, at astronomy. Okay, they just have an association, but nothing happens. They have a rover, replica of a Mars rover, but still they can't do much. Okay, yeah. Pratyush like, I love NITK. Then let me ruin it for you. Okay, I'll tell you stories of how horrible things are there. So yeah, if you want, yeah. Yeah, just anyways, this is some animation thing. Anyways, tell me, sir, why? Why would I tell you? It's just there. Just go. My friend works at NITK, so we know how things go there. What do you think part 6 will be? What? When do you think part 6 will be animated? Of what? I don't know. Okay, anyways, we'll get started. Guys, done with your cuddle break or whatever break that you have. Our complex numbers DPP is in your classroom. It's in your Google Classroom opens. It's in your folder somewhere. Oh, I have no idea, Shashank. Sir, in calculus, whenever we give it to an exponent value, it automatically takes a radian. Oh, you have to switch it. You have to switch it. There's a mode button at the top of scientific calculators. You have to switch it from degrees to radians. That's the problem. Radians is usually default everywhere, but you have to switch it. It's in the mode button there. Even in Google, if you're calculating cos of, by the way, why are you using a calculator? Yeah, if you're using this way, this works. You have to switch here, degrees and radians. You have to keep switching. Okay, even in Desmos, you need to, in the settings, you need to keep changing it. So you need to keep it in degrees or radians. So if you plot sine x, like for example sine x, it looks like this, but in radians, degrees, it looks like this. Horrible, right? Because the peak comes at 90 degrees. Okay, it comes at 90 degrees. So yeah. Do you teach chemistry also? No. I can teach physics, biology, and mathematics probably. Yeah. Biology I can because it's still a subject I love, but chemistry, no. You'll start hating chemistry for life. I'll scar you for life. Okay. Yeah. You won't be able to get up. Why bio? Bio is fun. It's just fun. And they say students love a particular chapter in 10th standard. 10th or 9th, there is one interesting chapter. Since everybody loves it. I don't know. I've heard. I don't know. Also in second piece, it's there. I've heard. I don't know. A human reproduction since, yeah, I heard. Yeah, I still remember, guys, this was so stupid. I'm telling you, I was teaching 7th standard. Okay, I don't know whether you guys have experienced 7th standard. Okay, I am doing a physics topic, ray optics. All the girls are giggling and asking, sir, are you teaching the next chapter? Guys are clueless. Okay, in 7th standard, all the girls asking, like, are you teaching? I'm like, what's so special about next chapter? I'm wondering. Okay. Then I realized it's human reproduction for some reason. Okay. And seventh standard kids, guys, seventh standard. Oh my God. Okay. Anyways, so yeah, thank God I didn't take that topic. Try sine x by 100. Yeah, that would work. That would work. You can do by degree by radians. You can divide, but sine x by 100 will be scaling the axis. So, oh, stretching. Sorry, sine x into 100 will be scaling. Then you can squeeze the axis a little bit. Yeah. Where is that game in your profile? I have no idea. 1 second. Shashank, what is left? Maths, Bharatanatyam, biology. I don't know. Okay. You teach only in CFL? Yeah. Only in CFL. Occasionally, I take some special class at Aloysius. Degree, some advanced theoretical physics courses, just like that with Winton. So occasionally, yeah, that's only for fun. Yeah. I have a master's degree in physics. Yes. Okay. Anyways, with that being said, we'll go ahead with the class. I think, can you guys come back to the webcams? You do only teaching. I have multiple projects going on. I do research. So, fun fact, I am currently working on a project from Spain, a bunch of researchers in Spain on COVID-19. So that's what I'm actually busy with. So yeah, so and I worked with a bunch of team from Bangalore on COVID-19. Apparently they were in charge of policy making and all this. So I was working on that. There's a project. Yeah, you have human reproduction 8th in grade, and since CFL teaches the 1 class ahead, that's how it turned up. Yeah, I get it. I get it. Yeah, but I love it how how that dynamic was shifting, because the girls were excited and the guys were clueless what was happening. That was exciting for me. That showed me that girls mature faster than the guys, little bit at least. Okay, just realized that day. Okay, really understood that really well. Okay, uh, what do you do seriously? Something seriously, all for fun. Yeah, this is fun for me. Coding is fun. But you're a physicist. Yeah, I told you, right? We physicists work on everything, whatever you throw at us. Shashank is like, I was in Spain for 6 months. Shashank MN. Okay. Now we're in Mysore. Shut up, sir. Okay. Not in Spain anymore. You can't brag. Okay. Uh, anyways. Yeah, except chem. Yeah. We don't love doing that. Although, whoever said hates chemistry, half of, like, I think 3 of my seniors who are doing physics are now doing chemistry in Germany. Okay. They're studying molecular dynamics, struggling with and stuff like that. Yeah. You love chemistry, awesome. Okay, it's fun. It's fun if you get the gist of it. Yeah. Anyways, when's the last date for public this thing breakthrough? I think it's today for CFL today, but you can write a mail to them saying you have some delay or something like that. But you can also but try to submit it to breakthrough competition by 25th, no matter what. Okay, whatever happens. Yeah, nice, Shashank. That's a good hypothesis. Okay, we'll continue, guys. Hope you guys are back. Yeah. Anyways, with that being said, so that worked. So that's the distance formula. Okay. So in case if the angles are not axes are not this thing, what is saying? It's going to be that way. Okay. Does anybody recognize this? This is where actually the use comes of these things. Real life application of these things. Okay, real life application of bent coordinate systems. It comes here. In fact, if you do relative motion in physics, you're going to see this, but dominantly you're going to see it here. Dominantly, predominantly. Not Kirchhoff's laws, not linear transform. Oh, by the way, fun fact: Kirchhoff's laws actually come from graph theory. You know, graphs, networks. There it comes from. It's not actually from. Yeah. This comes from. These are famous equations. These set of equations are very famous. Together. It looks like a tilted plate, but it's famous. There's an entire video made on this. I can click on it and show you, but not now. It looks like a tilted plate. Good. It's famous actually. It's very famous. Hint is, if you want a hint, C times T. Comes as C times T somewhere here. Yeah, it looks like a tilted chessboard. 1 second. I think I'll open this video for you guys. So just check it out here. Comes here. There's an entire video done by Minute Physics on it. Okay, my audio has been. What happened to audio? Can you guys hear anything? Is there any audio to this? Here it is.
The goal of relativity is to explain and understand
Kept the no audio for the first few sections. Okay.
How motion looks from different perspectives, and in particular from different moving perspectives. It's easy enough to describe motion
Look
itself.
At what he does. Look at what he does next. Look at what he does next.
Something is moving relative to me, that means it has different positions at different times, which I can plot on a space-time diagram. This straight line corresponds to motion at a constant velocity of, say, v units to the right every second. And the question we're interested in is, what do things look like from the moving perspective? Of course, the answer to this question is a physical one, and is determined by experimental evidence gathered by actually moving. And that evidence will come into play, but first we need to understand what it means in terms of space-time diagrams to view something from a moving straight vertical line through x equals 0. Or in other words, we want to make the space-time diagram into one where the cat's world line coincides with the time axis. That's not something we can do just by sliding the whole plot left or right or up or down, like we've done in the past for perspectives from different locations. No, changes of velocity require some sort of rotation-y thing to change the angle of the world line. And importantly, whatever this rotation-y thing does should be generalizable to a world line at pretty much any angle, since there was nothing special about the particular speed the cat happened to be going. There are also two important pieces of experimental evidence that we'll need to take into account. E equals 4, where it's at x equals
if you're interested, you can check on this video.
Sort of squeeze-stretch rotation. The reason these...
Einstein's relativity particularly, something called Lorentz transformations, you can check it out on your own. This is where these things tilt axis come in a lot. In fact, it comes up in a lot of geometry problems in mathematics. You can check it out. Some advantages. So good luck on that. I found this. You guys studied the distance formula now, right? Pythagoras. Yeah, just saying how things get complicated as you age. This is high school. This is somewhere in masters in physics. You'll come across something like that. This is Einstein's relativity. This is how Einstein writes Pythagoras theorem. Okay, I'm just saying what you've learned so far. It gets much more and more abstract as time progresses. Okay, this is Pythagoras theorem in a more complicated sense, and this is actually distance formula in any dimension. It works. These are distance formulas in much more complicated systems. Yeah, it looks like Chinese. Yeah, I get it. Okay, fine. What's partial derivative? This is that. This is partial derivatives here. Yeah, I know. Looks intimidating. Yeah, it has elegant. Oh, by the way, for those of you interested in computer science, you know this drill. Coordinate system. Computer scientists don't use this coordinate system. They use this one. A tilted y-axis. I don't know why. Actually, it makes sense. The pixels start from this corner here. This is a corner they start. And their axis starts downward, going downward like this. It increases this way. So minus 20 pixels from the top and 20 pixels to the right. Though computer science uses it this way. This is how coordinate system of a computer science. In computer science, it looks like. What's the difference between 3D and 5D? Higher dimensions. D, that's the difference. Oh, no. 5 and 3 is the difference? Yeah. Okay, that's the difference. You showed it in Sublime. Yeah. You guys remember when I did that session where I showed you how to control a mouse on your own? And you remember this was 0, 0 at the top. This point was 0, 0 at the top here. And mouse value went on increasing downward. Yeah. If you remember or not, it's fine. That day when we did it with your computers, we tried it. Yeah. Anyways, now I want to get into something. I'll tell you why this is so important. This coordinate transformation we are doing, right? I'll tell you why this is super important. Okay. I've done this for you guys. If you look at the solar system, and I've discussed this with you guys, would you like this figure or this one? I've asked you guys this before. Okay, if you view the world sitting on the Earth, this is what planetary motion looks like. It looks stupid, right? Imagine you have to study the motion of Neptune. You have to study the motion of the sun. It looks very complicated. You're going to sit on Earth and view everything. But if you sit on sun and view everything looks prettier. Everything looks sensible. It's like concentric circles, guys. You can do easy maths with this. Got the logic? It's one simple coordinate transformation where you look from a different perspective and do mathematics. Okay? My point here is very simple. Problems become simple when you do the right coordinate transformation. If you're smart enough and find the right coordinate transformation, you can solve problems quickly. Is this fine? That's my gist here. Yeah. Concentric ellipses, I know. It's not exactly ellipses, but my point is it's much more neater. The world looks much complicated when you see from the Earth. Yeah. So one simple coordinate transformation and it's done. By the way, this is what Mars looks like from the Earth, guys. This is Mars motion in the sky, how Mars motion looks like. This comes from very complicated dynamics, but that's because even the Earth is moving, so is Mars moving. So when we view the Mars from the Earth, it traces a weird shaped curve like this in the sky. But if you're going to sit on sun and watch this, like one, basically a line, that's it. World is simpler, it's a straight line. The question is, do you want to study this motion or do you want to study simple lines like this? These are simpler. Yeah. So my point is, this matters. Now, I just want to do this problem. You guys remember this problem? Where Murali solved this. So far, Murali has solved this. Keithan has solved this. I think Mithula has solved it and a bunch of you have solved this. Oh, by the way, this is Big Bang Theory. Yeah, the 3 cats problem. Do you remember this? Yeah, 3 cats at the corners of an equilateral triangle. And yeah, if you remember this. Yeah, this problem looks very complicated. Okay, at first sight. But this is my favorite problem in physics I know of, which I give first when people come into first PUC there. Okay, we throw this problem at them. Just, yeah, this problem is awesome for one reason. Okay, the question is 3 cats are on the corner. You guys know the problem, right? Cats on the 3 corners. And they start moving towards each other. This cat is interested in this cat. This cat is interested in this cat, and this one and this one. I go in directions. Okay. The question is, each cat moves with a constant speed, but the velocity keeps changing direction. The velocity keeps changing direction. Speed is the same. The length of the velocity vector is the same, but the direction keeps changing. They keep changing directions. Okay. Do they meet at the median? It doesn't make sense. What is median? Median is a line, right? Is that a line? Centroid you're talking about, I guess. Yeah. Okay. So do you agree this is what it looks like? Agree with me on that? Do you agree this is what the motion will look like? Okay, look at this part. This animation might be buffering for you guys a little. Is there buffering? Or did you guys get that? One cat follows the other. But do you think they meet? See, this is what the animation looks like of the cats moving. This is what the animation looks like of the cats moving. It's going to be a spiral like this, and they're going to do this complicated motion. So how much will they meet is the first question. They will end up meeting. I'll show you. They'll end up meeting. So A question is correct. They'll end up meeting. I'll show you. Okay. But the headache of this question is to figure out how much time will they take before meeting, one, and how much distance will they travel. Look at the complicated length they travel. It's a very complicated length. You have to calculate the distance, this distance, arc of this arc. This problem looks very, very complicated when you look at it. Just like, you know, you look at the motion of the Earth from this thing. What is that? Yeah, when you look at the motion of the sun from the Earth, or Jupiter's motion, or whatever, it looks much complicated, right? Yeah. Do you guys get that? Things rotating and moving and meeting at the point. They meet at the centroid. I'll give you that. Yes, they meet at the centroid. Okay, you guys saw the motion. Now, how to solve this problem? The problem can be solved in one stroke. And Keithan, can you help us here? You solved this before. What's the stroke? What's the master stroke here of realizing how to solve this problem? There's a master stroke here in this problem. I'll give you the microphone access if you want. Yeah, Keithan says relative motion is a key. Yeah, relative motion is the key. Look at how awesome this solution is. Imagine you sit on one of the cats. Sit on top of one of the cats. Just sit on top of one of the cats. Is that fine? Can I get yes or no? Clear with that? Now observe the world. Start observing the world. Cat will die, I know, but fine. Look, we live in a world where 3 cats are chasing each other. Okay, in a very predictable manner. Okay, yeah. So do you agree this is what the motion will look like? Do you see there'll always be an equilateral triangle between the cats as they move because of symmetry? Whatever it is, it starts with an equilateral triangle, but then the cat's motion will always trace an equilateral triangle. Agree with that? Can I get a yes or no on that? As they go from the corners. It'll be complicated, but it'll look like this thing. No. It's just out of symmetry. They'll always maintain this distance, relative distance, whatever it is. There'll be an equilateral triangle if you visualize it. Okay. Now here's the interesting part. Sit on top of one of the cats and observe the other cat. What will it look like for the other cat? don't you think it look like as if there is a triangle which is simply shrinking like this? An equilateral triangle whose sides are only shrinking, that's all. Agree with that? Can I get a yes or no? If you're sitting on, ignore the rotation. If you ignore the rotation also, that's happening. If you just sit on the cat and observe. Basically, I'm using a rotating coordinate system here, a coordinate system which is continuously rotating. My point is, if you sit on this cat, do you guys agree with that? Got that part? For this cat, it's going to just look like as if the two cats are coming towards it. Do you see that? Did you guys get that part? It looks like as if two cats are just going towards it. The problem looks now very simple, as if two cats are just going towards another cat. Now that is something very easy to solve, right? If you figure out what speed with which this cat is moving towards this cat, relative motion, you can just take this distance and divide by that velocity, done. Divide by that speed, you're done. Getting the logic? Since this triangle is only shrinking, that's all. You just have to take the speed with which they come towards this cat, what speed they come towards it, and just divide by the distance. You're done with the time, you get the time. If you take them to be zero-dimensional points, shouldn't they keep circling each other? Yeah, kind of, but they'll still end up meeting. No, I'm not altering the question. I'm just saying you sit on the cat. You're observing the world from the cat's point of view, one of the cat's point of view. Basically what I'm saying. Yeah. No, all cats starts instantly. All the cats, three cats start together. Okay. Hope that's fine. Yeah. Oof. They start instantly. Okay, they start instantly. One cat follows the other one. Yeah, there's always an equilateral triangle. So if you use relative motion and start the coordinate transformation, this problem becomes super easy. Okay, there are many such problems which we'll be studying in second PUC, first PUC, where there'll be rain-based problems. There is an interesting problem which I do in volume 2, where there's a car and there's a method in which you can go at a speed at which the car's back window doesn't get wet at all. The back panel, what is that called? What's that thing called? The thing at the back. How do you calculate velocity? That's hard. I won't teach you that. That's advanced trigonometry. You require a little bit of trigonometry to solve this problem, to get the velocity in that direction. It's not easy. The rear window, yeah. The rear window, yeah. Yeah, maybe. The rear. Okay, the back panel, the rear, whatever that is, that need not get wet if you go at a rear windshield. Okay, fine. Okay, with that being said, just think about that. Found more memes on Reddit, if you want to see. By the way, this is me. Okay, occasionally asking you guys. I think I've told you, right? I always mess up the spelling balloon. No, I think it's this. People have corrected me. Yeah, this is the one. Yeah. Real analysis? No. You just can't. Could we use the relative velocity formula? You can. But unless you know, first of all, how do you know even to use the relative velocity formula? Unless you are smart enough to figure out that actually there's a relative motion happening in the first place and that there is some sort of transformation happening. Do you have a PhD in math? No, I don't have a PhD in physics itself. What in math? That's Shiba. Okay, nice. I did not know that. Why is 5 plus 7 hard? Sometimes you forget. We use calculators so much. We know how to do integrals, but we don't know how to add 5 plus 7. Okay, just saying. Yeah, just like Howard all over it. Okay, anyways. Now I'm going to revisit an old example. Okay. Now this, Medansh, you have some amazing memories with this. Okay, this is an old example, guys, from 8th standard. Some of you know about this. I'm bringing it up again. So you know the drill. You know why I have this card? We're going to do a kidnap. Okay, so the usual example. Yeah. Now the question is, kidnap used to be my favorite example back in this thing. Why Medansh? Because we kidnapped Medansh back in 8th standard in that batch. Okay, I still remember it. Okay, now with that being said, we need a kidnap, guys. Just a normal day in Prajwal's life. Yes, I get it. So by the way, quickly, we'll do the problem. We need examples. Who's going to be kidnapped, guys? Volunteer, self-volunteer. Pratyush is getting kidnapped, done. Who's driving the Omni? Who's driving? Who's doing the driving? We need a driver. Fast. Shashank MN. Okay, Shashank MN is the driver. Next, who's the mastermind of the kidnap? We need a mastermind. That is Medansh this time. Okay, good. Okay, Sakshi this time. Okay, fine. Sakshi came first after Medansh. Okay, Sakshi is the mastermind. By the way, who's putting the petrol and all that stuff? We need somebody to assist a little bit. Okay, Prajwal. Okay, fine, done. I am the. Oh, I'm getting the Goni Chila, everything. Pratisha's house. You guys plan that. Okay, fine. We have everything we need. Where are we kidnapping to? I'll tell you. Wait, 1 second. So the everything we need is here. We start. Why are we kidnapping, by the way? I don't know. Why are we kidnapping? Or to take her to her crush. Okay, that sounds like a plan. Good. Awesome. Sounds like we are taking her from the wedding mantap and carrying her to her someplace or something like that. Okay, fine. Sounds like a plan, Pratisha. Thank you for volunteering. You will regret this. Going ahead. Okay. Wait. We are taking her where? So we have decided we are taking her from Mangalore to Bangalore. Why? I don't know. Sounds like a plan. Sakshi's plans. I don't know. Ask Sakshi. Okay, she's the mastermind. Okay, Sakshi, what do you want to do with her? First of all, do you have any plans with her? What to do? Like we are doing what you say. You're the mastermind. Okay. Okay. Anyway, she doesn't seem to throw her off a cliff. Vivek has some suggestions. Pratyusha, you're gonna hate this. Okay, Vivek, you're so dead. You're going up against Pratyusha. Pratyusha. Okay. Oh, Sakshi. Fine. So Sakshi is like, yeah, that sounds like a plan. Okay, so we are throwing her off the bridge somewhere in Bangalore, it seems. I don't know why. She knows swimming. Pratyusha, do you know swimming? Then that doesn't work. So yeah, that doesn't work. Come on, come up with something better. We need to tie our hands or something. Yeah. Anyways, with that being said, now listen to this. We kidnap her from Bangalore. Fine. Then we drive. Shashank being a good driver. Oh, by the way, Shashank, Sakshi, he's asking for his fees, driver's fees, advanced. Okay, done. Give it to her. Okay, fine. Tie to a tree. Okay, fine. Chlorophyll. Oh, guys, I know you have cruel ideas. Keep them to yourself. We'll ask them later. First, we'll reach Bangalore. Okay, we'll try that later. Okay, yeah. Now, finish the job, then he gets paid. It says, okay, Shashank, shut up. First, do the job. Okay, Sakshi says that. Okay, now, with that being said, let's continue on. So we take her from Bangalore to Bangalore, but then we being very good kidnappers. First of all, we are very good kidnappers. I agree with that. Good kidnappers. So we give a break for her somewhere here. Okay, this location we give a break. It's roughly about 300 kilometers, let's say. We give her food. What food shall we give Sakshi, by the way? Ganjuta? What are we going with? Yeah, nice kidnappers. Good, you're good, Reddit. That's a good one. Professional kidnappers. Okay, Ragi Mudde. Ragi Mudde sounds like good. Yeah. So we're going to, I know it's 369. We'll take it as 300. Problem becomes easy. You want to do problems with math problem with 369 kilometers? Up to you. Good luck. Okay. So listen to this. So let's say we're giving her pizza, French bread. Okay, nice, awesome. Pratyusha, you're gonna love this kidnap. Okay, so we're kidnapping her, and we're giving her a break somewhere. We're giving a break exactly at I think I've discussed where. Somewhere we're giving a break halfway in between. Okay, we're giving a break halfway in between. Yeah. Now, the question is, where do you think we stop? At what distance do you think we stop to give her a break? Yeah, we'll come to that. Satvik, 1 second. At what distance would we stop? This is 0 kilometers and this is 300. What distance would we stop? About 150, right? Half of that. Halfway through, we stop halfway. Not in America. Depends on the mood, it seems. Okay, fine, dude. Yeah, Shashank is driving. He's really fast. Okay, no questions about that. Sakshi has appointed an excellent driver. Anyways, with that being said, we stop exactly half. By the way, it has been said that you guys know this happened in the February, the zero traffic corridor. Somebody took took a baby from from Mangalore in under 4 hours. Now, Medansh being Shashank being very good at this, he actually he drives really fast like this. Okay, some compliments to him. Let's say this time, for some reason, we give her a break early because she feels hungry, and we being very good kidnappers, we give her food a little bit early. But this time we stop 1/3 of the journey. We stop at here. The duration, and Shashank being a steady driver, he drives with the same velocity. The question is, if it is in the ratio 1:1, our distances, what is this distance? Come on, tell me. At what distance do we stop? Come on, you guys know this. Easy stuff. Keithan, not exactly. We'll come to that. Yeah. Yeah, it's 100. How did you do it? You did 300 and then divide by 3. Is that fine? Yeah. Hey, by the way, Sakshi, are we giving her ice cream? Gutbud or whatever, something. I don't know. As a souvenir, like for being kidnapped. She should feel good, right? Tiramisu, it seems. Okay. Nidhi, yeah, kinda, but I'll go step by step. I'll build it up. You're surely giving good, but 1 second. Who are you to decide where to stop? Shashank is asking. Okay, no. Sakshi's orders. We are stopping there. Okay, she's the boss here. Okay, you drive. You're the driver. Maximum, that's what you do. Okay, done. I am the guy yelling on the back of the van. Okay, your worker. But I get direct orders from Sakshi, not you. Okay. Anyways, now yeah, kinda. I'm getting there. Okay. Yeah. With that being said, we'll continue. This time we stop at a different rate. This time we are pissed off, let's say, different type of section. We stop at 2/3 of the journey. Then tell me how are you going to calculate what's the distance? Come on. This is very easy. You're going to multiply 2 divided by 3 and get the answer. That works very well. 200. You guys are very good at this. Yeah. How many times will you kidnap her? We're just coming up with different plans. Okay. Sakshi's drawing the blueprint and we are discussing it. Okay. Yeah. Anyways, with that being said, this time let's do it in a different style. 3:1. Tell me where. What if? Oh, we forgot the police in the story. Who's going to be the police? Chasing Shashank at the back. Okay. Okay. You can tell your own name, by the way. Just saying. Okay. Satvika on an Airavata? Okay, fine. Something. Okay. Fine. Anyways, something. Anyways. Yeah, that sounds like CID. Okay, fine. Anyways, it's going to be exactly 225. Agree with this? Some of you messed up a little bit. It's 3/4 of this thing. Agree with that? Police is Nidhi, it seems. Okay, fine. Satvika, the sub, whatever. Okay, done. They are riding from the back, and Shashank, you better run. Okay. Okay, anyways, by the way, Shashank, again, Sakshi's orders. You stop where we ask you. Okay, done. Fine with this 225, guys. Can I get yes or no? Fine with this. Orders for Shashank to stop at 225 kilometers. Yeah. Okay, done. With that being said, that works. But this time, what I'll do is I'll write as 3+1 for some reason. Okay, next part. This time, for some reason, Sakshi goes to Sakleshpur. So we don't kidnap her from Mangalore. We kidnap her from a different location. Okay, from Sakleshpur, which is roughly about 120 kilometers, but we take it 100. Satvika, she says she's Nidhi's driver. Fine, good, awesome. Yeah. Sakshi is not in the getaway car. She's the mastermind and gives orders. Yeah, I understand, Sakshi. Yeah, you are in your mansion and giving orders. I understand. Okay, done. Anyways, with that being said, this time we stop exactly halfway in between. But at what distance do you think we'd stop? At what distance? Remember, from Mangalore. But this time we started from Sakleshpur, which was already 100 kilometers. How do you solve this? Think. How do you solve this? Yeah, you guys know this, right? This is 100, this is 100, and this is 100. So you're like, this is exactly 200. Common sense, right? The whole distance is 200. Okay, at a distance 200. But how would you go about actually solving? If you do it mathematically, you would go about subtracting this distance first. That is 300 minus 100. Agree with that? 300 minus 100, and then divide that distance by 2. Okay, and then add it to 100. Agree with that? Got the logic? You do that? Okay. Mastermind. Fine. Yeah, I'm getting there. Satvika. So do you agree with this? Can I get a yes or no? You take this distance divided by 2 and this thing. Add 100 because I started from Sakleshpur. I got this distance to be 100. This duration is 200. I divide that by 2 and get that 100 length. And then add it to 100. Is that fine? Clear, everyone? Okay, I can go ahead. We'll go it quickly. So this time we stop this way in the ratio 3:1. Yeah, I know, Nidhi. Yeah, anyways. Yeah, this time, what are we doing? Tell me. There's a formula in coordinate geometry for this. I know. What's the fun in using the formula? But yeah, Medans is like, you kidnapped a girl just to find distances. Okay, that's what we do, guys. We're good kidnappers like that. Yeah. Anyways, do you agree this time you're going to multiply that distance by 3/4? Agree with that? You're going to multiply that same 200 distance, but this time by 3/4. Yeah, we're scientific kidnappers. Fine. Yeah, and then add it to 100 this time. Agree with this? Can I get a yes or no? Clear? Yeah, I'm getting there. I'm getting there. I'm getting there. This is section formula. Yes, we're going there. We're going there. That's the journey. Okay, but I would prefer writing this 4 as actually 3 plus 1. Is police following me? Are they sleeping? Nidhi, where are you? You've been asked. Okay, anyways. Satvika is sleeping, I guess, the driver. Okay, anyways. With that being said, yeah. Anyways, yeah, you packed anything and forgot skills. I forgot. I didn't get that. Okay. Pratisha says, will Nidhi help me? She's crying out for help. Police and all that. So, okay, fine. Thank you for yelling. Okay. Anyways, with that being said, this time I'm going to stop in the ratio 3:2. Tell me. Yeah. Nidhi is like, Satvika, wake the heck up. Yeah, please. Yeah. Yeah, sure. I know, Satvika, fine. Is this fine? Can you tell me what's the distance now? Tell me. 220? 220. But this time, do you agree I'm going to be dividing by 3:5, 3 by 5? Yeah, yeah. 3 by 5, 3 by 5. I'm going to be 3 by 5 into that distance. Yeah, I know, Keaton. All of you told was section formula. I'm getting at section formula. Yeah. Yeah. So this becomes 220. Now, if you observe, the general procedure here is you have 3 and 2, and you have 300 this distance, and you have 100 here this distance in the formula. These are all the elements that you need are this 100, 300, and 3 and 2. Okay. Now, I'm getting to section formula. So I can simplify this way. Do you agree with this? Multiplying 3 inside. Fine with this? 3 times 300, 3 times 100. Distributive law. Fine with that? Can I get a yes or no? Just, yeah. Now, can I do this? I'm taking this 100, multiplying by 5 and dividing by 5. Is this fine? I'm keeping rest as it is, but I'm taking the 100 and divide by 5 and multiply by 5. Numerator and denominator. Shashank is like, I'm waiting for my fees, Sakshi. Yeah, later, we'll see. We have not concluded the story yet, what happens. Okay, just give it some time. Yeah. Is this fine? Got this bit? Can I get a yes or no? 5 by 5? Yeah. Now, can I take 5 common out from this whole expression? Or before that, can I take this way? Can I do it this way? Fine with this? Yeah, this makes sense, right? This makes sense. Now, if I would, why 5 by 5? Just like that. Because I'm multiplying by 1 to 100. Okay, that's it. Multiplying by 1 to 100 because I'm crazy like that. Okay, I just multiply 1 to random things and keep them the same. Okay, fine with that. Now, with that being said, so this works. So I can take 5 common out, the denominator, common denominator. Okay, now 5 times 100 minus 3 times 100, what is that? Do you agree it's 2 times 100? 5 minus 3, makes sense? Can I get a yes or no on that? Okay. By the time you all calculate, Pratish will be snoring on her bed, it seems. Okay, fine. I know. Kidnap has to be planned. Come on. It's like money heist. Okay, it has to be planned very well. Okay. If you read in the same thing, you'll get this. 3 times 300 plus 2 times 100 divided by 3 plus 2. Is this fine? Money heist, yeah. Yeah. Guys, got this bit? It basically ends up you having to multiply 3 times 300, basically 3 times the other coordinate plus 2 times the previous coordinate. Does that make sense? Can I get a yes or no? It's always 3 times the opposite coordinate plus 2 times the previous coordinate. That's how I remember it. Okay, it's always the other coordinate that gets multiplied. 3 times 300. Yeah. Okay. That's section formula. Now, this can be done in general if your ratio is m:n, and if these points are x1 and x2, then the same derivation looks like this, x1 plus this thing. I'll tell you why this section formula is much more important, because in computer science, this matters a lot. This type of formula derivation matters a lot, because you'll be doing calculations like this all the time. But do you get the essence of it now? Where does section formula come from? The derivation, where it comes from? It's basically that. It's basically this. It's adding this distance plus finding the ratio, m by m is 10. Yeah. Now, if you simplify this expression, you get 3 times, instead of 3, I have m this time. Oh, by the way, I forgot this. Oh, x1 and x2 are this time 100 and 300. Okay. Yeah. Is this fine? What is x? Oh, x is this point. X is this distance. I'm trying to find x. Okay, x is that distance. from the Mangalore up till that, I don't know, luxury point for Pratyusha, wherever she enjoys a snack or whatever. Yeah, yeah. By the way, we have some more fun examples if you want. You guys have to suggest multiple crimes which you want to commit. Up to you guys. But kidnapping sounds like a better one because, yeah, sounds like fun. Anyways, with that being said, you can simplify this accordingly. Earlier I had 5 here. I'm multiplying and divide by 5 by 5. Rearranging and doing it, you get the same formula. This is a section formula. This is a section formula in one dimension. Okay. Yeah. So it just works. People are saying smuggling and genocide. Wow. You went from kidnapping one person to murdering 1,000 people. That's an upgrade. Sakshi wouldn't want to do that. I don't think so. Yeah. Anyways, guys, is this fine? It's a derivation of the section formula. It's how section formula comes. Okay. It's not that complicated. It's just the same thing. You just have to look into the previous what we did with calculation and then simplify it. You get n times x1 plus. In place of x1 and x2, there was 100 and 200. Is that fine? Guys, fine with this? Oh, we'll end the story. Guys, what happens to the story, guys? We kidnap her, then what do we do? We need to end it, right? What happens to Nidhi and Satvik? That also has to be concluded. We can't leave them in the story sleeping there the whole till the till the end. We need to do something. When will we reach Bangalore? 4 hours, guys. 4 hours. That's your fees. Okay, Nidhi wants to end it well. She ends up with her crush happily ever after. Done. Okay. Okay, fine. Now I'm wondering, what is Sakshi really up to? If she's trying to get Pratyusha married or something like that, I don't know. Okay, they die in a car crash. Okay, multiple endings. Fine, guys. You create your own version. Pick your best version. End the story for yourself. Go to sleep tonight. Okay, get a good night's sleep. Don't sit thinking about it. Okay. Shashank, okay, nice ending. Where's my fees? Ask Sakshi. I don't know. Yeah. What's this? I didn't get that, Nidhi. Okay, I can get that. One second. Nidhi, Sakshi is asking for her fees. Okay. Sakshi is like, he screwed up on the job, no fees. No, I'm not. No, I'm not. I'm sorry. No, sorry about Harry Potter. Yeah, no. So all we know is Harry Potter. That's all. Okay. Anyways, should I pay the? Why should I pay the goddamn police? No, Sakshi, you're not paying. Satvika needs a fees for driving. Okay, that's all. Yeah. Anyways, with that being said, we're done. This is a section formula in 2 dimensions, guys. So x is yeah. 1 second. X is that distance, the total distance from Mangalore. We're trying to find out where where we have to give her a break. Okay. Okay, is that fine? That is the one hell of a kidnapping. I'm tired. Yeah. Yeah, Shashank has some other plans. Good for you. We'll continue on for now. Okay, fine. Anyways, yeah, done. So that's section formula for you guys. So it tells us if you have a distance, if you basically what section formula does is, can you go to the previous slide? This slide. This slide. Yeah, is this fine? Yeah. Okay. So what it does is, I'll explain for others. So if you have a line, if you have basically a line segment, and if you have 2 points, that is P and Q, and we know that there is one more point in between in the ratio 1:2 or m:n, then it gives us this distance from O till that point, whatever that distance is. Okay, fine with that? Can I get a yes or no? Hopefully everybody got this part. Just basically saying. Yeah. Look, to be honest, I don't know how to give you section formula, guys. You already know it. Only way is to put that masala on top of kidnapping. Okay. Otherwise, I don't see a way to put it in your head. Okay. By the way, section formula works for even tilted axis. You can bend the axis, and this is in 2 dimensions, not just in 1 dimension. If you want to do it in both directions, x and y, then you do it in this idea. So if you have 2 points, 1,2, and some point, let's say 4,5, and then let's say there is a line joining those 2 points. There is somewhere a point in between which divides in the ratio 1:1 or 2:1. We want to know the coordinates of those 2 points, x and y. And the x is given by this formula, and y is given by the other formula. And I want you to remember this always. It's always m times the other coordinates, m times the other coordinate, x2, n times the previous coordinate, that is x1. Is this fine? Can I get a yes or no? Just remember this at the back of your heads. Done. This is for 2 dimensions. 1 second. Who's that sending multiple messages? 1 second, 1 second, 1 second. I'll be kicked out. Okay. 1 second. I don't know why are you. Some of you are so much attention seeking. Okay, 1 second. Wait. I missed half the messages. Thanks to you guys. 1 second. Wait a second. I missed some messages. Okay. 1 second. I have to scroll. Damn it. Okay. 1 second. Okay. It's timer? Guys, is it timer? 6 minutes. I'll ruin next 6 minutes of your life while I'm at it. Okay. I'm sorry. I missed some of the questions that came in the last 1 minute. You can send it again if you sent anything, please, guys. Okay. I missed something. Okay. Anyways, I'll just do a problem. Can you solve this problem for me quickly? There is a point. Oh, by the way, this is not. There's no quiz today. This point is not 13,25. I forgot to edit it. It's 14,27. Okay. Is there a section formula for polar coordinates? Yes. There's a section formula for all coordinates. Okay. It just there are, depending on the coordinate transformation, you guys have to apply the formulas. Okay. What is this point? In between, exactly in between. Basically, I'm asking what is that point in between exactly. No, you'll understand. Just use the formulas in that slide. Okay. So tell me what is that point exactly. Come on. You guys have not solved any problem. It's a midpoint. It's exactly the midpoint. What is that midpoint? So for those of you who don't know the calculation, these are the formulas. Basically, you take m times, that is 1 times the other coordinate 14, plus minus 1 times n is 1 again, times the other coordinate 2, divided by m plus n. By the way, Keaton, not a lot. You guys are not behind. No. Okay. So this gives us 8. Is this fine, guys? Calculation, everyone? By the way, some of you messed up the calculation. It's 8,15. Midpoint is a special case of the section formula. Yeah, it's just midpoint formula is a special case where you have 1 and 1, the midpoint. Your calculation is wrong. Did I make a mistake? Guys, is that correct? No, right, it's correct. It's 1 times 27, the other coordinate, times 1 times. The question is wrong. I know. This question is wrong. That's what I told you, right? It's 14,27. That's a mistake there. Yeah. Is this fine, guys? Got it? Why is that point stupid? I don't know. I'm just annoyed with the problem. Okay. I don't know. It's just, yeah. Okay, there is a fun game which I want to play in the class once. I don't know when to do it. It's a game from, Jimmy Fallon. I don't know if you guys know the show, Jimmy Fallon. No, it's just to make it fun, that's all. It's where I give a question. I write down an entire question. And then I leave blanks. So for example, there is a point, I leave the blank. Okay. And I ask you guys to fill in those blanks. But the way I ask you guys is I won't tell you what's the story. You might have heard of Mad Lib Theater. Have you heard of Mad Lib Theater? It's one of my favorite games on Jimmy Fallon. Watch it if you're interested. Okay, watch it with Benedict Cumberbatch. You'll love it. Mad Lib Theater. So Mad Lib Theater with problems, but okay, it's a fun game. So I was like, why not use it? Okay, so it gives you 8,15. Is this fine? Everybody find the calculations, guys. Can I get a yes or no? Can I go ahead? Okay, good. Does anybody have issues with the calculation? Did not get how to solve it or anything? Who has not been in CFL before or something? Because I've gotten it. I know. I have 3 minutes. I'm making the most out of it by asking, did you guys get it? Come on. Be honest. Don't give me a no here. 3 minutes, guys. I feel like I'm dying. 2 minutes. I feel like a countdown now. Come on. I'm losing breath. No, seriously. Guys, got it? Don't lie to me. It's just section formula. Go with the color coding, guys. It's x2, x1. This is 1. M is 1:1. Okay. Shashank is asking for guys. Sakshi, is that sarcasm? Yeah. Okay. Vivek is like, you can die peacefully. Okay. Shashank is like, I want distance formula. Can you teach it, please? No, I can't. I can't. I can't. I don't know why. I totally didn't get it. Yeah, that's sarcasm. Thank you. Uh, by the way, if you don't believe me, go to Desmos, plug in the values, observe, and tell me. Okay, do the experiment yourself. It works. The formula works. Is it fine? Yeah, I know. To its limit of exoneration. One second. Okay. Is this fine? Got it. On a serious note, did you guys get it? It works. I don't know why I'm asking it now. Okay. Even if I add a serious note, that doesn't work with you guys. Okay. Yeah. Okay. Beg properly, it seems. Yeah, I know. Guys, by the way, it's still that same thing, but this time in the ratio 1:2. Tell me quickly, last one. 14,27 itself, but 1:2 ratio. Tell me, what is that point? We'll close the day with this problem if you do it well. Come on. Get used to the problems and do it quickly. Pratyusha, at the end of the story, you're alive. Happily in the hands of your crush. We have delivered. Done. Sakshi has done a great job with it. And it's done. Okay, you can thank her later personally. Anika, seriously? The problem is right there. I was color coding, guys. M is in green. N is in red. What more can I do? This is like basically the coloring book from first standard. You take the numbers and put them there. It works. Okay. With the help of Vulkan, I think it should be possible, Shashank. I don't know. Yeah, Rahul, you're right. Sumit, you're right. It's yeah, one of the coordinates is 6. Some of you might have said, Navya, you're right. Yeah. Srijan, you're right. Anvita gave me one coordinate, 18/3. Yeah. Anika, I know. Okay, fine. Satvik, I got it. Yeah. Anvita's messaging speed is too slow. Like 6 and then 11. Okay, fine. Good. Awesome. You guys are great. Cheers. Have a great day. Get done. Okay. We'll continue the story next time. We've ended the story. Okay. Happy ending. And yeah. So in the end, the driver doesn't get anything. The driver goes home. I don't know. Meets his wife. Says no money. Actually didn't give any money. Not even pocket money. Nothing. Okay. Coding sessions, I'll let you know. It's not there mostly, but because we're busy with the breakthrough challenge thing, it's going on. So in case if there is, I'll let you guys know. Yeah. Turns out Shashank didn't hear whatever I said. Shashank ML. Thankfully, good. Yeah. You guys can leave. We're done for the day. No quiz because I'm not done with the topic where I can conduct the quiz. So I'm just gonna leave you guys today. Next time, everything will be included. What happened to you in the story? Oh, I am in the back of the car rotting for eternity. I don't know. I just left myself there. Okay. Yeah. You see, I'm leaving my daily job by cleaning the window, cleaning Shashank's car. That's my job. Okay. If he doesn't have money, what will I do? Okay, done. End of the story. Switch to wedding photographer. Yeah, that could be possible. I could do that. Yeah. But whose wedding? Okay. Anyways, Shashank is good boss. He'll pay me. Okay, fine. Sakshi, please pay him now. Okay, I need my money. That's it. Okay. Anyways, with that being said, where can I send the video? It's the marketing ID which has been given to you. What about Nidhi? She gets promotion. Inspector to something. I don't know. Commissioner. Okay, done. Happy ending. Everybody's happy. Sakshi is like, I own the car, not Shashank. Okay, you own it, but he's going to pay me. Done. Okay. Anyways, marketing ID. Yeah, please go through Schoology. There is an ID given. Please use that. Is that fine? Yeah. So bye-bye, guys. You guys can attend Pratyusha's wedding, it seems. She's welcoming you guys. So, tata. Bye-bye. You're done. Look at the smile on her face, guys. Getting married face. Okay. Anyways, sorry. Yeah. Nihad is coming only for biryani, it seems. Okay, fine. Sounds like a plan. Pratik's like veg only, it seems. Okay, fine. Veg biryani, done. She's serious about this, guys. She's even planning this. She even knows it's veg. Okay. Yeah. Anyways, guys. Yeah. Good day. Yeah. See you guys. You have any questions, guys, about this thing? Oh, by the way, Nidhi's offering to be your bridesmaid. Okay. Yeah. And the bachelorette party she's organizing. Okay. Pratisha. Nice. Hope I get invited now. The car cleaner guy. Okay. Yeah, this sounds like a How I Met Your Mother story. Okay, I know. Okay, anyways, Anika is organizing reception. It feels like we're organizing a wedding now. Guys, who's in charge of catering now? It feels like we're organizing it. Who's in charge of lighting? Who's in charge of that? Oh, we could have a problem like that. Oh, Kamath caters it and done. Okay. Yeah, I know. Pratisha won't forget. Invitations with him, Sai Pratiksha. Good. Awesome. Wedding cards. ID for what? I don't know. Head of what? I missed that. ID for what? I didn't get that, Vivek. Okay, I missed it. Yeah, fine. You guys keep organizing the wedding. No quiz today. So do what you want. I'm making the chats public. Give you 5 minutes. Do what you want. Okay. Yeah. Others, any questions, guys? Owner of the all, it's Sanika. Okay, fine, done. In charge of venue and everything. Yeah. Beach wedding would be fine. We would love that, but anyways. I can't believe we made a math class into a Swayamvar. Okay. Sakshi is the blessing, it says. Okay. Oh my God, Pratisha is changing this thing tilt only now. Mine or wedding? You want to organize mine? Okay. Our wedding. I think we have 2 Reddit pages coming out of this. Yeah, you can. Sounds like a plan. Look, the chats go private if you organize my wedding. Okay, start organizing mine. Yeah. Oh my God, you guys are crazy. Yeah, thank you, Nidhi. Thank you. Yeah, I think I have to switch to private now before my wedding gets started. Done. Private chats only. Done. What? What's her crush's name? I don't ask her. Yeah. How sad, right? Yeah. I am not married, of course. What do you think? 5 kids? No. Wow. Okay. You guys seem to be doing family planning for me also. Dozen kids. Okay, fine. Bachelor party. Okay, Nihad, you are in charge. Kids' names, you guys don't have to pick. I'll pick. Okay. Family welfare. Nice one. Our family welfare plans. Okay. Sounds like a plan. Okay. Anvita wants my age. It seems. What you're doing? Take a kundli and doing that part. That's your in charge. Okay, fine. Do it. Sai Pratiksha, new house. It seems. No, I don't know. Let's see. What's your age? My age is 25. Exactly 25 on last week. Yeah. Yeah. Pratisha, like she'll find the girl. It seems fine. Good for you. Yeah. Thank you for the wishes. Yeah, belated happy birthday. Yeah, that's what people were wishing in between the class that day. Okay, those wishes started came. I was like, how did you guys get to know? Yeah. Anyways. Masters at 25. No, I finished masters 2 years ago. Yeah. Anyways, before we start organizing my wedding and it goes too far with all the planning, like you guys planning my insurance, life insurance and everything. Bye guys. Okay. See you guys. Yeah. She's even planning my child's birth rates now. Okay, fine. Good for you. Okay. Anyways, see you guys. Take care. Yeah. Yeah. I don't want that planning now. That's too much. Too specific. Yeah. Yeah. Anyways, see you guys. Take care. Any questions other than the Swayamvar part? If you have anything else, yeah. Why is the Earth a cube? What? I have no idea. Anish. Anish, was it Anish? Yeah. Okay. I'm tired. Organizing a kidnap, a wedding, and then my wedding. Something. Okay. Anyways, uh, yeah. Anyways, guys, go to your own planning. Bye bye. Okay. I know you have a Zoom group for that. Yeah. Anyways, bye bye. See ya. Yeah. Anything else? I think I'll end the meeting. Amit, I have no idea. Yeah. Bye, guys. Take care. And yeah, see you guys. Yeah. Pratisha, bye bye. You missed it on it. Congrats on the wedding. Yeah. Thank you. I'm happy about it. Really happy about it. Although I do not know who the girl is. Yeah. Somehow I'm married suddenly. Okay. Anyways, bye bye, guys. That's what arranged marriages are, though, right? You get married to a stranger all of a sudden. Okay. Anyways, bye bye, guys. See ya. I'm ending the meeting before you guys actually get me married. Bye.